This is lecture 1.2 of the algebra playlist, and exponents are just simpler ways of expressing larger numbers. An example of an exponent would be 2 to the second, or even 2 to the third, or the fourth, or the fifth. Now, these numbers you see here would be the base and the exponent, which are presented in this format. If you could see down here, in where my cursor is, it's highlighted. This is the computed way of writing this out, but on paper, this is what you would write. Except we can't do this in computers, so this is what we type out. We use this, the up arrow, to define to the power. Now, in exponents, you have the base and the exponent, as I said before. The base would represent the number being multiplied, and the exponent would represent the amount of the number. So what I mean by that is, let's say 2 to the third. That means it's 2 being multiplied 3 times. So this 3 of the base in each one is multiplied. Now this can be used for any number such as 3 to the third, which is equal to 3 times 3 times 3. 3 multiplied 3 times, which is equal to 27. Now, this can also be used as 7 to the second, even 5 to the fourth, or any number in between. Now, there's some rules to this, such as 7 to the 0. Now, you would think 7 being multiplied 0 times would equal 0. That's the only thing logical about that. But in math, when a exponent or a base, I should say any number or a base is to the 0 power. By the way, when you talk about exponents and you say to the power, that means the exponent to the power of 0, or to the power of 1, or to the power of 2. Or you can say cubed. No, it's not. This is squared, and this is cubed. To the second is squared, and to the third is cubed, because squared, it represents the area. So let's say a perfect cube would be 4 times 4, which means 4 to the second would be 4 squared, because a perfect square would have the same amount of sides, which is 4. 2 4s, which can also be represented as 4 to the second, which gives us the notation or the nickname 4 squared. And then there's 4 cubed, because when you have a cube, a perfect cube, the area would be 4 times 4 times 4, which we get the nickname 4 cubed, because it's a cube, a perfect cube. Now, going back to the 0 power. It seems like it should be 0, but it is actually 1, because in math, when you have, let's say, 4 to the third times 4 to the 0, we have this rule because this would completely disrupt the whole equation, this whole equation. If 4 to the 0 power were equal to 0, let's say this is canceled out and equal to 0, then the whole thing would equal to 0, which messes up everything. So we have it equal to 1, so that if 4 to the third times 4 to the 0, if this section was equal to 1, then it would end up equaling 4 to the third, 4 to the third times 1, which doesn't doesn't disrupt the equation because 1, any number multiplied by 1 is the same. So this is why we have this rule. Now, using variables in this, such as x is equal to 3, then x to the third is what? If, oh sorry, if x is equal to 3, then 3 to the third would be what number? It would be 27. So let's say x is equal to 3 again, but this time 3 to the x. X equals to 3, so the x is replaced by 3, so this time the exponent is 3. So it would be 3, so 3 times 3 times 3, which is equal to 27, which can also be used for any sort of combination of numbers, such as 5 to the second is 5 times 5, which is also equal to 25, or x is equal to 2 or 3. So let's say 5 to the third is equal to 125, because 5 times 5 times 5 is equal to 125. See, this is the logic behind variables, and that will complete this section of the lecture, and I hope you guys got something out of this video, and stay tuned for more algebra.